Good morning. Today we are going to discuss about the energy from the sun. It is our second lesson in our 8th class. Already you know the earth on which we are living is full of varieties. What are that varieties? The variety of landforms are there on the earth's surface. The plains, plateaus, valleys, and the places which have the scanty rainfall, which have the heavy rainfall. Like these, we have the variety of types, variation on the earth's surface. This is called diversity on the earth's surface. And today we are going to learn about the another diversity, that is called diversity in the temperature. Diversity in the temperature on the earth's surface. Generally, we observe in the morning we feel cool, and while the day is growing, the temperature, the warm conditions are increasing, and in the evening again it cools down. In the same way, in some months we feel cool conditions, and in some other months, for example in summer months, we feel hot. And also some of the regions and places have the diversity in temperature. For example, polar regions that are covered by the ice and the equatorial regions, they receive more temperature and they are very hot. So you know the tropical zones, temperate zone, polar zones. So like this, the temperature is varied from one place to another place, or in one period to another period. And the difference between the temperature of two places causes the moving of winds and causes the rainfall. So generally, all the human beings and plants will require the temperature and heat or water. For the plants for making their food, they require the solar energy and also water from rain. So these difference of temperature among the different places is causing heat and rainfall. Generally, some of the plants, they are growing in cold conditions and cold regions, and some of the plants, they grow in the hot conditions, and neither of the plants grow in very cold conditions. So these are the variations in the temperatures, and these variations of temperatures are affecting the animals and the plants on the earth surface. Okay, so which is giving this energy? Sun is the principal source, main source of giving this energy in the form of heat and light. So the earth's surface, we are getting the solar energy in the form of light and heat. We can feel it. Of course, it is coming in different forms. For example, it is in the form of UV rays, X-rays, in the form of light, and in the form of heat, and the other types of rays are also there. So we are receiving the sunlight. The sun, it is a storehouse of energy. It is releasing the energy. So any body which emits, which exposes, which releases the energy is called the radiation. So solar radiation. What is solar radiation? The sun constantly, the sun constantly emitting the energy. So the sun releasing the constant energy is called the solar radiation. Solar radiation. But nothing but the energy which is emitted by the sun constantly is called solar radiation. Okay. The coming from the sun, the energy is emitted from the sun. Energy is released by the sun is called solar radiation. So, what is solar? What is insolation? Solar insolation. Insolation means incoming solar radiation. Incoming solar radiation. The radiation received by the Earth's surface. The radiation received on the Earth's surface is called insolation. Of course, the sun is giving 100% of the energy. Sun is emitting, releasing 100% of the energy. But the Earth's surface is not receiving that 100% of energy. It receiving some portion of that energy. The small portion of about 30% of the energy released from the sun is reflected like a mirror reflecting the light. So the small portion of the solar radiation, about 30%, is reflected directly into the space by the atmosphere and the clouds and the Earth's surface. So the atmosphere and the clouds and smoke and dust, they are absorbing some portion of the energy and they are reflecting some portion of energy. And how much amount of energy is receiving and how much amount of energy is reflected, let us learn now. So this insolation, coming solar radiation here, the observes, it is absorbing, it is reflecting percentage. Observing percentage, this is reflecting percentage. And which are absorbing and which are reflecting the solar radiation? There are the three factors are there. One is the atmosphere and the clouds and the Earth's surface. These are the three things. They are absorbing and they are reflecting. About 70% of the solar energy is absorbed by these three aspects, three things. 70%. The remaining 30% is reflected directly into the space. Okay, the atmosphere, by the atmosphere, the 16% of energy is absorbed. And the clouds are absorbing 3% of energy. And the Earth's surface, it is absorbing 51%. You can see a picture in your textbook also. So totally 16%, 3% plus 51%, it equals to 70%. So we are observing the Earth's surface and atmosphere and clouds, and including atmosphere and clouds, the Earth's surface is receiving totally the three aspects are receiving 70%, and only the Earth's surface is receiving 51%. Okay. How much amount of energy is reflected into the space? Already 30% of energy will be reflected directly into the space. Okay, the atmosphere is reflecting 60% of energy into the space, and the clouds, smoke and dust, all are covered in this, are reflecting the 20% of the energy, and the Earth's surface, it is reflecting the 4% of energy. Totally 6 plus 20 plus 4 equals to 30. 30% of energy is reflected into the space directly, and 70% is observed by the Earth's surface and clouds and atmosphere including. These three are absorbing 70% and these three are reflecting 30%. This is about the insolation. And also, how this 30% is reflected, in which form this 30% is reflected, is by the conduction process. By the conduction process, 7% of the energy from the 30% to 7% of the energy is reflected, and by the latent heat process, 23% of energy is reflected directly into the space. Totally 23 plus 7 is equals to the 30%. So this is the energy we are receiving from the sun and reflecting into the space. Sun rays and the earth surface. The sun rays and the earth surface. The sun rays which are falling on the earth surface are not heating up the earth surface uniformly. Some of the areas will be heated up more and some of the areas will be heated up less. So what are the causes behind that? You know, the earth is in spherical shape. It is round like a ball. It has some curvatures. Due to that curvatures, some of the sun's rays are falling directly at 90 degrees and some of the falling directly in various angles. Of course, the energy of the sun falling on the earth's surface equally with a slight variation sometimes, but it is releasing the constant energy throughout the year and the year to year also with a slight variation, though some of the regions are receiving more and some of the regions are receiving less, and some of the regions which have the more temperature, some of the regions which have the less temperature. So for that there is a reason. There are some reasons. Out of them is the curvature of the earth. Curvature of the earth is one reason. Due to this curvature, the sun rays which are falling in the equatorial zone, they are falling directly at 90 degrees. And the rays which are falling slantingly, by bending slantingly towards the poles, when we go towards the poles, North Pole or South Pole, the sun rays are falling slantingly by bending, and also the distance is also more. To reach from the sun, the energy is emitted by the sun and it travels towards the equatorial zone. It takes less distance than the poles, North Pole or South Pole, or other than the next places to the equatorial zone, towards the north or towards the south. It traveled from this place to this place. The distance is less than, and here to travel towards the poles, the sun rays traveled more distance than the equator to reach the equator. This amount of distance is traveled more than the traveling towards the equatorial region. So the distance is more. The traveling distance is more than the equatorial region. The traveling distance towards the poles is more than the equatorial zone. This is one cause. and also the area, the occupied area of that rays is less at equatorial zone, because the sun rays are falling directly. The sun rays are falling directly in the equatorial region. The area occupying by these rays is less, and this area is more. The occupied area by sun rays other than the equatorial region, and especially towards the poles, is more. So due to this large occupancy, due to this short occupancy area, it leads to the variation in the intensity of that rays. Intensity of that. For example, the sun rays are falling directly in equatorial zone, directly, and the spreading area of that rays, the spreading area of that rays is not much than the polar zones, other zones. So the small amount, the radiation amount, the solar energy, the rays are falling from the sun in equatorial zone, it occupies less area. When that rays are falling in less area, automatically the intensity is more, the power is more, the power of that rays is more, the heat is more. When that rays are spread over the large area, that intensity is lessened. Due to that, the other than the equatorial regions, due to this curvature of the surface, the sun rays are falling in larger area, so the intensity is lessened, so the temperature is lower than the equatorial zone, in other than the equatorial zone. When we move from equatorial zones towards the North Pole or towards the South Pole, the temperatures are decreased due to this curvature reason. This is called the angle of incidence. What is the angle of incidence? The angle is formed by the sun ray falling on the earth's surface. Falling on earth's surface. This is the earth's surface, and the sun ray is falling like this. The angle is created here. At the equator, 90 degrees, and when we go towards the North Pole or South Pole, and the angle is increased. The angle is increased. Due to that increase, they are receiving the less amount of heat. So these are the, what is the angle of incidence? The angle of the ray which is falling on the earth's surface is called angle of incidence. So this type of angle is formed with the rays falling, the point at which the rays are falling to the perpendicular to the earth's surface, is called angle of incidence. So the angle of incidence in the northern hemisphere, the angle of incidence in the northern hemisphere is increased in the November and December months. In the November and December month, the angle of incidence is increased. When the angle of incidence is increased, when the angle is increased, automatically the intensity is lessened. Due to that lower intensity, it leads to the low temperatures, less temperature on that areas. And the angle of incidence is decreased in the months of May, June. the angle of incidence is lessened here, decreased here. Due to that, in the May zone in the northern hemisphere, we feel hot in summer season. This is the winter season. So this process, this angle of incidence is decreased and increased is caused by the revolution of the earth around the sun. Due to the revolution of the earth around the sun, the movement is occurred. Due to that movement, the angle of incidence is changed, reduced and sometimes increased. So it is increased in November and December and reduced in May and June. We can observe the insolation receiving at different latitudes. The amount of energy, the amount of radiation we are receiving at different latitudes. You can see at the 0 degree latitude, for example, 100 units are receiving. The 0 degree longitude is receiving 100 units. Then at 45 degrees latitude, only 75% units are received. And at the 66.5 latitudes, only 50 units are received. And at the 90 degrees, only 40 units are received. We can observe the difference between them. So here at the equator 0 degree longitude, the sun rays are falling directly. They are falling 90 degrees. So the intensity is more and that rays are occupying less amount area. Due to that occupying less amount area, it leads to the high intensity. This high intensity causes to the higher temperature in the equatorial zones. And at 45 degrees, the curvature is increased. The curvature is increased at 45 degrees. Then it reaches only 75%. The sun rays falls slantingly. Due to that 75 units are received. And at the 90 degrees, the sun rays fall more slantingly. So it receives only 40 units. So this is the variation in the angle of incidence. This angle of incidence causes to the variations in the temperature also. Land and water contrast. The distribution of temperature over land and water is varied. You know, the land is heated up quickly and cools down quickly, and the water is heated up slowly and cools down slowly. Due to this variation, land became as the good conductor and water is not like that. The atoms in the water are far from each other, and the atoms in the land very nearer to each other. Due to that, the temperature received by the land is spread immediately or within the short period. It receives temperature and it releases temperature within the short period. And the water, which receives the sunlight slowly and distributes that temperature, the spreading of that temperature to the bottom layers of that water, the process is done slowly. So due to the variation in receiving and releasing of temperature between the land and water, it leads to the variations in the temperature over the Earth's surface. This is also one important reason. for the variation of temperatures on the surface area of land. And temperature of atmosphere. Temperature of atmosphere. Temperature of atmosphere. Generally, the temperature gets heated up only by the terrestrial radiation, not by the sun rays directly coming from the sun. So the atmosphere is not heated up by the sun rays, not heated up by the sun rays directly. The atmosphere is heated up by the radiation of the earth. Radiation of the earth. What is the radiation of the earth? Only the atmosphere allowing the sun rays towards the earth's surface. Sometimes there is a ozone layer is there. This ozone layer is obstructing the harmful rays, ultraviolet rays, UV rays. The ozone layer obstructing the harmful UV rays only, and the other rays are allowed to reach the earth's surface, but they are not heated up by that sun's rays. Only the atmosphere is heated up by the terrestrial radiation. Terrestrial radiation means the energy, the temperature, the heat released by the earth. Once the earth is heated up by the sun rays. And the atmosphere, what is atmosphere? The gaseous layer is surrounded the earth's surface is called atmosphere. So automatically the layers of that gases surrounded the earth also heated up by the earth's heat, earth's radiation. So they attached the atmosphere layer, the gaseous layers attached to the earth's surface. Due to that attachment, these are heated up only by the earth radiation, terrestrial radiation. Next, heat balance. What is the heat balance? What is the heat balance? The balance between the received amount of the solar energy, solar radiation, received amount of the solar energy, and the released solar energy. For example, the earth is receiving 100 units of solar energy, and the incoming solar energy insolation is 100 units, and the earth terrestrial radiation also 100 units. It means incoming solar energy 100 units, outgoing solar energy also 100 units. It is equal. For example, it is not equal. The total amount received by the total energy received by the earth's surface is retained on the earth's surface. What will be happen? It accumulates. The energy is accumulated day by day. For example, on the one day 30 units are received, second day 30 units, third day 30 units. It equals 90 units within the 3 days. And by the days are going on, the energy is accumulated over the earth's surface. So it leads to the destruction of the living things on the earth's surface. So earth becomes hotter and hotter. For example, it releases more than the received amount. For example, it is releasing more amount than the received amount of the energy. Then earth becomes cools. Then automatically we never see the living things on the earth's surface in the future. So the balancing is created. The balance is created. So this is called heat balance. The heat is received 100 units and the heat is released 100 units. Of course, the energy from the sun received toward the earth's surface is retained for some time to protect the living things on the earth, animals, plants and human beings, other things. Due to the layer of the CO2, carbon dioxide. Due to the this carbon dioxide layer is obstructing the terrestrial radiance somewhat. Some portion of the energy is retained for some time. Of course, 100% it will be released for some time to protect the living things on the earth's surface. And after that time, it is released fully. And again in the next day, the earth is receiving the solar energy from the sun. Automatically, it warms up the earth's surface. So this is the process it is going on. Here, for example, due to the overuse of petrols and cutting trees, due to the deforestation and consuming the fuels, these are created the chlorofluorocarbons and the CO2 is increased by that. When the CO2 is increased, the CO2 is obstructing more than the requirement. The CO2 is obstructing the terrestrial radiation, the which heat is going outward from the earth's surface is obstructed by the CO2. It is stopping. Some portion of the terrestrial radiation is stopped by the excess CO2 and other gases, chlorofluorocarbon. So, by increasing the CO2, the terrestrial radiation is disturbed. What is terrestrial radiation? The releasing heat. We have received the 100 units from the sun and we are releasing the 100 units. Again Earth's surface is going to cool down the Earth's surface, because next day it will regain that power, regain that energy from the sun. This losing of energy, this releasing of energy from the Earth's surface is called terrestrial radiation, and this terrestrial radiation is somewhat, it is useful, obstructing the terrestrial radiation. It is useful to protect the living things on the earth. After that, the some portion of the energy also obstructed by the CO2, also it will be released slowly, gradually it is released. So CO2 is obstructing for some time. But here the CO2 level is increased, the CO2 proportion in the atmosphere is increased. What will be happen? It obstructing the terrestrial radiation and it leads to the earth warming. It leads to the increase of the heat on the earth's surface. It is called global warming. Global warming. The earth's surface is warming up slowly. It is heated up slowly. It leads to the so many destructions. So the heat balance is the important to protect the living